Hi, welcome to this lesson on Linux basics. This is going to be an introduction to some Linux knowledge, command line, interface, and terminal information that is really useful for when you're on an HPC cluster. So what I'm going to cover are some command line tips and tricks, mainly some keyboard shortcuts that are really useful. I'm going to go over some commands that are useful when you're on an HPC system, which I've broken up into 4 different categories. Navigation, which is kind of navigating a directory tree structure. Information, which is like getting information about files. File information, copying files, moving files, deleting files. And finally, getting information about processes, like what you're running or moving stuff to the foreground or background in Linux. I'm going to talk about environment variables, what they are, how they're useful, and some of the special ones that kind of Linux or your shell will automatically set and look for. And then finally, I'm going to talk about shared software stacks and how you interact with these. So a lot of HPC centers will install a lot of software that multiple groups need, and usually you can get access to this through what's called the module system. So first off, I'm going to talk about some of these keyboard tips and tricks. So the very first one is that tab will autocomplete whatever you're trying to write. So if you're trying to type in a command that you only remember like the first half of, like say you have a binary called like parse files or something and you have it in your path, you can start and you don't remember if it's like parse files with a capital F or lowercase f, you can type in parse, hit tab, and it will try to autocomplete. If there are multiple options that it can think it can autocomplete to, it typically will list those out. If you hit Control R, this will search through your history to try to find whatever it is that you type in. So you hit Control R, type something in, and it will start looking through your history to try to find it. This is really useful. If you have like a command with a bunch of arguments, you don't remember the exact order or the exact flags, you can use Control R to get back to it. Hitting Control E at the same time will go to the end of a line. So say you had to fix a typo at the very start of your very long command. Say you have like a command that has like 5 or 6 arguments. Then you need to put in a 6th one at the end. So you like fix it, whatever it is at the start, you hit Control E, and it'll go to the end of the line, and you can start putting in additional arguments. Similarly, hitting Control A will go to the start of the line. So say you type your command, you put in your 10 different arguments, and you realize that you typoed the initial command. You can hit Control A, and it will move your cursor to the very start. The next 2 you might have to set up in your terminal, like as an option, like going to like settings and setting it up. But if you hit Alt on a Windows box or Linux box or Option on a Mac and hit Alt Option plus F, it will move you forward a word in your command line on your shell. And hitting Alt Option or B will move you back. Finally, hitting Control and U at the same time will clear everything before your cursor. So say you have a whole bunch of stuff in your terminal, you just want to start from scratch, you can hit Control U and it will clear everything. Typically, you can, in most terminal programs, you can still scroll up and see what was cleared. This just kind of lets you have a current clean slate. All right, let's see some examples. I'll show a little bit of all those little keyboard commands and shortcuts. So let's start off with the bash command line tips and tricks demonstration. To start off with, I'm going to show off the tab autocompletion. And so right now in my terminal, I did an ls command, which just lists what's in my current directory. There's a demos directory and an examples directory. So you can use this autocompletion to either find commands or fill in something after a command. So let's just say I want to see all the commands that start with CA. I can type CA and then hit tab a couple of times and it will print out all the commands that start with CA. And then let's say I want to use the cat command, the CAT command. And then I'm like, oh, I don't know what I want to use it on. I want to use it in something. Can you type in, hit D and then hit tab and it will autofill in this demo directory. And if I hit tab a couple more times, it will show everything that's in the demo directory. So I can say, myfile.txt. I cat it, prints out what's inside of it. And we'll talk a little bit more about these commands later, like cat and ls. If I want to see, like, search for something in my command history, you can use the control plus R. You hit them both at the same time. It will bring up this reverse-i.search colon text, and then you can start typing something in. So if I want to see everything that I've done with my demo directory, I type in demo. You can see in the first part is what I typed, colon, and then whatever it finds in my history that has demo in it. If I want to search for older entries, you can continue to hit Control R, and you'll see that it comes up with other commands. And you can hit just up to get out of that. I want to show how to move to the start and end of a line. So let's say I have like this is a very long command, and we can just pretend this is a really long command with a bunch of flags. And then let's say that I need to get to the start of this. I need to turn this into a question. I can hit Control A to go to the start of the line, and then I can type, is this a very long command with a bunch of flags? And then I need to go back to the end to add a question mark. I can hit Control E. So Control A takes you to the start, Control E takes you to the end. Also, a bunch of terminals have options to move back or forward a word. This is usually Alt or Option plus B to move back a word, or Alt and Option plus F to move forward a word. So I'm going to hit Option and then B will move me back some words, or F to move forward. This is terminal dependent though. Finally, let's say that I want to clear off everything but this question mark, or let's say all I care about is a bunch of flags. You can hit Control U, and it will clear out everything in front of your cursor. And then you can type something else. This is a bunch of flags, or something like that. And then kind of finally, let's say I just want to clear out my screen. You can type clear as well. And that about wraps it up for the demos on these kind of Bash command line tips and tricks. So let's talk a little bit about navigation now. When you log into an HPC cluster that's running Linux, which is a flavor of Unix, you're placed into a directory, typically your home directory. If you want to learn how to kind of navigate it around, or if you're unfamiliar with the directory structure of Unix, you can kind of think of it as a tree. So the first thing is the slash directory, the / directory. This is the root. All other directories will be under this one. Each directory that you enter, so like /home, is moving down the tree. And so you could do like /home / your username, for example. All users have a home directory. So in this, there are going to be some special files that will allow you to configure your shell, or run stuff automatically when you log in, usually like setting environment variables and things like that. And then to access different directories in Linux, you use what are called paths. There are two types. The first is an absolute path. This will start from root and is like the exact location of something. So if you have a file in your home directory called test, an absolute path would be like /home / your username / test. There are also relative paths. So that starts from your current location, where you are in this file directory. So if you're in your home directory, home / username, to get to test, you would just be able to access that test file. Edit test. You don't need to put in the /home / your username. So there are a few commands that are useful for navigating a directory structure. The first is the pwd command, which is print working directory, and this tells you where you are. It will give you the absolute path of where you're currently located. ls is the list command. You can kind of think of that as like what's around you. It'll list all the files and directories in your current directory. And then you can also pass it a few flags to get a little bit more information. And then finally, there's the cd command, the change directory command. This will move you into different directories. So you do like cd directory, so you're using a relative path to go there. You do cd absolute path to go somewhere. If you do cd with nothing else, or you do cd space tilde forward slash, typically that will return you to your home directory. And if you need to move up to a parent directory up one level, you do cd dot dot. So say you're in home, your username, test directory. If you wanted to get back to your just username directory, you do cd space dot dot. And now I'll show some examples of all of this to kind of give you a little bit of a feel of what I'm talking about. So let's show off some of these navigational commands. So first off, let's figure out where we are in the file system. When you log into a Linux-based HPC system, you usually end up in the home directory. So it'll be /home/ your username. Let's confirm that's where we're at using the pwd or print working directory command. And we can see that's where I am. I'm going to use the ls command, which I'll talk about in a couple slides, but this will just list directories and files that are in the same directory that I'm in. In this case, we can see there are two directories, demo and examples. I'm going to change directories, or cd, into the demo directory just to see what's in there. And then I'm going to do another ls just to see what's around. And in this case, I have some directories, file manipulation, my folder 2, processes, rsync example, and I have a text file, myfile.txt. Again, I can do a pwd. You can see that I'm in the demo directory, and then I'm going to use what's called a relative path to go into my folder. A relative path is based on what directory you're currently in. So I can just type in like cd my folder. I don't need to type the whole absolute path. And if I do pwd, again, you can see I'm in /home class 37 demo my folder, and that is the absolute path. I'm going to show a few ways now to get back to your home directory. One is just to show how you can go up a directory. You can use the cd dot dot command, and that will move you up one, and then I can go up another cd dot dot to go back to kind of my root, my home directory. And then to show an example of an absolute path, like the exact path of where you want to go, if I do home class 37 demo my folder, you'll see that I'm going to end up in this /home class 37 demo my folder. I'm going to run a command called clear real quick just to make sure that everything stays on screen. This will just clear out my terminal. And then I can actually scroll up like this to see what I had typed. It doesn't actually get rid of it. It just kind of makes it where you start at the top of your terminal again. And there's pwd, so we're here. Another way to get to your home directory, you just use cd, nothing after it, and hit enter. And you'll see that I'm back in /home/ class 37. And then if I go back to my folder, I can also do cd space tilde /, which will also take me to my home directory. And with that, that'll end this set of examples. Okay, now that we've talked a little bit about navigating the file directory and the file system, let's talk about actually getting information about files. In the previous section, I mentioned the ls command. You can also pass it some options or flags. This is usually like a dash in a letter or a dash in a word to make it do a little bit more stuff or give you a little bit more information when you run it. Some kind of examples here are like ls-a will show every file in a directory, even ones that are what are called like hidden files. Usually if something on Linux has a dot or a period in front of it and then its file name, like your .bashrc, when you run an ls without the -a flag, it just won't show up. ls-l will give you a lot of information about it. ls-t will sort the output by like modification time. And then you can also combine these commands. If you do like HLT, that will show you all the hidden files, give you all the information about it for that the -l flag shows, and then we'll also sort it. And then finally, this last one at the end with the R in there, we'll do the we'll sort it in reverse order. So the newest things end up at the bottom. Another command which is pretty useful is the which command. This will show you the location of a file that's in your path. So say you've loaded up some software modules on an HPC system and you're trying to figure out where your GCC compiler is coming from, like if it's the system one or the one that the HPC center installed, you would type which GCC and it will tell you where that file is located. The less command will let you view a file. So you can run this on anything in Linux, but you definitely want to run it on mainly just text files. If there's any like binary data in there, you'll just see gibberish. But if you do like less my file, it will show the contents of that file and let you scroll through it. The cat command will display the contents of a file to what's called standard output. That's like your command line. So if you do like cat my file, will just print everything in your terminal. And then you can also then start piping commands to it, like grep to try to find something or things like that. The head command will list lines at the start of a file, and you can pass it a flag and tell how many lines after the very start of the file that you want to be able to view is. This can be useful if you have like a header in something and you want to make sure that it's correct. Tail does basically the same thing as the head command, except it lists the lines at the end of a file. And again, you can pass a flag to it to say, print the last line plus, 100 or something like that. So like the 100 last lines. And yeah, I'll show some examples of all of these too, because they're pretty handy. And then once you use them with what's called a Linux pipe, they become very powerful. All right, so let's show off some of these informational commands. You've seen me do the ls command a few times, so let's pass it some flags. If I do ls-l, it gives me a little bit more information about each of the files, such as like file permissions, the size, user and group ownership, and the modification time. If you pass it the H flag, it will try to put stuff in human and readable format. None of these files, unfortunately, are big enough to really matter, though. Generally, it will take the sizes and put them in like megabytes or gigabytes. If I want to look at all the hidden files, I could do LA, and you can see all these ones with dots in it are hidden by default. And then if I want to sort them, I can do LTA, which will sort them from newest to oldest, or I can do the reverse order, which would be LRTA, which will put it from oldest to newest. Another command that can be useful is the which command. So let's say I want to know where my GCC compiler is. So like on GCC version, I can do which GCC. And then it'll show user bin GCC. That's where this executable is located. If I go to examples data, so this is going to be an example later on, but this is just the text of Alice in Wonderland. If I want to see the file, I could do alice30.txt, and you can see that this is the Project Gutenberg version. I can scroll up and down to look through it. If I want to have it print out to standard output, I'm going to do one of these smaller ones. It will print out to my terminal. If I just want to look at the first set of lines on one of these files, I could do head. And you can see that it prints out just the beginning of it. It doesn't print out the thing. Oh, yeah, you can see that it only prints out the beginning and not the whole thing. And then I can do the same thing with tail as well. It will only print the very bottom of that chapter. And then just a couple of flags. You can say, hey, I want to see the first, like 5 lines of Alice in Wonderland or of this text, which is the, disclaimer or the last 5 lines of Alice in Wonderland, like that. Let's talk about some process commands now. So first off, if you just want to know what's currently running on the system, you can run the top command. This is interactive, so if you try to run this by submitting a job to your HPC cluster, you're not going to see anything. So this is an interactive program that will show what's currently running, how much CPU these commands are using, how much memory, and things like that. You can also use the PS command. This will show by default with no flags the processes that are running under your username. But you can pass it some flags that will show everything on the system. This will also show you what your process ID or PID is, which will be useful for the next command, which is the kill command. So the kill command will basically stop a process. So say you're running a Python script and it gets stuck in some weird infinite loop. You can do PS to find what the PID of that number is, type kill PID, and it will kill that process. The next command can be a little confusing. It's this: you type in whatever command you want, space ampersand, and it will run the process in the background. So what does that mean? Typically when you run something in Linux, so say you do Python 3, myscript.py, it will run. And then you won't be able to do anything with the terminal until that process has completed. If you do Python 3, myscript.py, space ampersand, it will run it in the background, which will basically let you still do stuff in the terminal. It basically assigns it to a CPU, does it. It won't show you any of the output for the most part, depending on how you set up your command. And it will just run. This can be useful once you start submitting jobs to an HPC cluster. The FG command will then take a background process and move it to the foreground. And now I can show you a few examples of all of these. So let's run through some of these examples. I'll start off with the top command, which is an interactive way of seeing what's currently running on a node, on a system, and shows all users. Some useful information here is the PID, process ID of processes, the username, the percentage of CPU and memory that's being used, the time something's been running, and the command itself. To quit out of it, you just hit the Q key on your keyboard. Next, I'll show the PS command. This just shows what you yourself currently have running and the PS command itself. If I had other commands running in the background, or if I had multiple terminals open, it would show these as well. When you run a program on a Linux system, by default, if you don't do anything with it, no putting that ampersand after, you run it in the foreground. So I have this sleep.sh program. All it does is sleep for 30 seconds. You can see it's entering sleep. I can't do anything. I can't, put in any commands or anything like that. To exit out of this, I can just hit Control C. If I want to run this in the background, you do, program name ampersand, and this is going to pop up an index number in brackets, as well as the process ID for it. And then you can hit enter, and I can either do ls sleep.sh. That index number lets me bring this back to the foreground by doing fg1, which is that index, and you can see I'm back in sleep.sh. I can't do anything. Control C out of that. And then if I want to kill the program, so let's run this in the background. Let's say this is a program that actually uses a ton of resources. I'm on a login node and I get a message that I'm not supposed to run this on a login node. I need to kill it, move it to a compute node. The way to kill it is you can take the PID from running it in the background, or do a PS, and we'll see that I have this PID here, and you just do kill PID. It'll kill it. If I do PS, it'll say, it's terminated, and you won't see it anymore. Actually, it looks like I do need to kill the sleep as well. And so my two processes are dead. And that's just a quick rundown and some examples of some of the process commands on an HPC system. Now let's talk about environment variables and wildcards. So these aren't actually related, but they're just kind of small enough topics that they can be added onto a single slide. So to start off with environment variables, these are just a variable, kind of like in a programming language, that are available in your shell. So you can set the name of something to equal something else. So, for example, say you have an environment variable for your name. So you could say, like, whenever you type $name, it will just substitute in your name if you said it correctly. Some of these have special meanings to your shell. So, like, their path, $path, will be where your shell looks for executable binaries. Your LD library path is where your shell will try to find shared libraries that some of these applications might need. To set one yourself, you do export variable name equals whatever. So it could be export name equals your name. And every time you type $name, it will replace that in whatever you're running with your name. They're very powerful in shell scripts, and knowing what ones you need to configure to like compile things is also pretty important. Next are wildcards, and this is just a way to run processes over like multiple files, especially if you have files that conform to like their file names conform to some sort of pattern. So say you have a list of data files that are just like years. So you have like 1900 to 2025. That's the name of these files. You can use wildcards to match files in there. So say you wanted to just list every file and do an ls of every file that is in like the 2020s. You could do ls 202 question mark, and it will match 2020 to 2025. So if you use the question mark, it only matches one letter. And if you do a star, it will match one or more letters. So what that means, so say instead your files are like year, month, day. So like 2025-01-01 is a file. If you wanted to match all the 2020s, you could do ls 202 star, and then it will list off all files that are in the 2020, 2020-0101 to 2025-12-31. If you just do the question mark, so say you do ls 202 question mark, then you have to add in like -01 -01, and it will only match like January 1st in all of those years. I'll show some examples that'll make that a little bit clearer, but wildcards are very powerful when you're doing like file listing or processes over a whole bunch of files. So yeah, let's get onto those examples. Let's run through some examples. So first off, let's set an environment variable. And just to prove that the environment variable we're going to use is empty, we're going to try to echo it. To reference an environment variable, $name a variable. My var is empty. If I want to set it using bash, we're using the bash shell. You do export, name a variable, no $sign in front of it. You only use the $sign if you're referencing it in a command or a function. Equals whatever you want. This could be another command. It can be just a string. In our case, we're going to have a string that's called my variable. And then we'll see that it gets set there. If you want to see what environment variables you already have set, you can use the printenv or env command. Both of them do basically the same thing. You can scroll and see, things that are set, like your man path, your hist size, shell, things like that. Or you should be able to grep my var, and it shows up there as well. A couple of common environment variables would be your path. This is where your shell looks for executables, programs to run. And then there's the LD library path, which is where your shell looks, your compiler will look for shared libraries and things of that nature. Each of these are basically a list of directories separated by a colon, and your shell will look in each location for that. So let's say that I have an executable that I want to run without having to do the absolute path. Like for example, in my examples bin directory, I have a script called hello script. All it does is say hello. Let's say I just want to be able to type hello script to use it. It can't be found. You can add a directory to your path to do so. But let me back up my path real quick though, because there is one caveat here. Your first response might be, hey, what if I just set my path to the location of where I want my script to be? Just examples bin. And then I can run hello script, and yeah, everything looks like it's great. But then I'm like, oh wait, I want to run ls. Oh, it's broken. And that's because my path is only this one directory. So the way that you'd want to do it, let me set my path to what my old path was, my original. You'd want to do something like export path equals new directory, so my examples bin, colon, my current path. You can reference the current value of your environment variable when setting them. Now I can run hello script, and I can run ls, and things will work. All right, let me clear my screen, and we'll go talking about the wildcard values. So let's go to this directory just to run a couple of examples. Examples, data, years. If I do an ls in here, I have files from 1800 to 2025. And so if I wanted to just find certain patterns of files, let's say everything in the 1900s that ends in 7, I can do 19?7, and it will find that. It will find them. The question mark, because it only replaces a single character, I can't do like 19 ? To try to find everything in the 1900s. Whereas if I want to use the asterisk, which will replace one or more characters with anything, it will find everything in the 1900s. That's just a couple of quick examples for the wildcard characters. Okay, let's talk a little bit about software, specifically shared software stacks that HPC centers provide. So most HPC centers will usually provide multiple versions of all the software they install. This could be due to like different releases, say every year or two they build another version of whatever libraries they're supporting or software they're supporting. Or it could be they might build software using multiple compilers, like say the Intel compiler or the GNU GCC compilers. And there's a whole bunch of reasons for that. It could be for like performance or what people want or use. To manage this, it's often provided or by modules. And all a module is it's something that will set environment variables, such as like your path or your LD library path, so it can find the software, and shared libraries, and a way to kind of search through a software stack. There's also usually some sort of code or ways to flag conflicts. So you're not like loading multiple versions of the same software or incompatible software. Like usually they stop you from loading a library built with Intel and then a library built with GCC at the same time, because that can just cause all sorts of problems. There's a bunch of standard module commands, but kind of the big thing that's the first thing to kind of know is if you're using TCL modules or LMOD. LMOD is newer and is written in Lua. TCL was like kind of an old way of doing it. LMOD has more functionality, uses more commands, makes things a little easier to search. And it's becoming more and more popular. It also, by default, uses what's called a hierarchical naming scheme. All this means is that when you run certain commands, it will only show you modules that you have available based on what you have currently loaded. It's kind of a way to try to not overwhelm people with information. The way you use modules is you type in module and then the command that you want to do. With LMOD, ML command also works if you just don't want to spell module all the way out. And some common commands are like module avail, and this will show you all the modules that are available. And so in the hierarchical naming scheme, though, it will only show you what's available based on what you have loaded. So as you build up and load more modules, when you run module avail, it will show more modules that you can load because you're meeting more and more prerequisites. If you just want to search and not have to like build up to something, you can run module spider. And I should note these are all for LMOD. TCL doesn't have like the module spider command and doesn't use the hierarchical naming scheme by default. Module spider will search whatever keyword name that you put in and list the modules that are available. And then if there's only like one module available, it will show you what you need to load to access it, or it will show you all the versions that are available, and then you do like module spider software name / version, and then that will tell you exactly what you need to load. To actually load a module, you do module load module name. And then kind of related to that is the unload command, which will, if you do module load module name, it will unload a single module. Or if you want to get rid of everything, you just do module purge. And again, these will only mess with like environment variables. So it's not like installing software, deleting software for you. If you like purge your modules, you can get them back. You don't need to worry about anything like that. And here, let me show you some demos on using modules now. Let's start off with the modules I have loaded. You run module list and you'll see what's currently loaded. And then if I like echo my path, you can see because I have the Slurm module loaded, it has modified my path. And I can use module avail if I just want a list of all the modules that are currently available. And then you can expand this if you load other modules. It kind of builds up and more modules become available based on what you have currently loaded. So if I load the GCC 11.3.0 module and then do module avail, you'll see that I now have more modules available. Then I'm going to run module purge to get rid of everything. If I'm searching for specific modules, you can run the module spider command. So it's module spider name. So let's say I'm like, oh, I want to find netcdf. This will tell you what versions are installed. So it gives like a description. It tells you what the versions are. And then you can do a module spider of a particular version. And in this, it will tell you what modules you need loaded before you can load that. So if I like load Intel compilers 2023.1.0, sorry, module load, and then module load IMPI 2021.9.0, I can then load netcdf 4.9.2. You can unload specific modules. So let's say I don't want, the Intel compilers loaded anymore. You can do module unload, and then it will tell you what won't work because those modules aren't loaded anymore. And then if I echo my path, you will see all these modules have modified my path. And if I do a module purge to get rid of everything and echo my path, you'll see I'm back to the default. Those are kind of the most common module commands, and I hope that was useful.